How to choose an optic fiber fusion splicer. Before introducing to you how to choose an optic fiber fusion splicer, let us first briefly introduce to you the working principle of the optic fiber fusion splicer. The working principle of the optic fiber fusion splicer is very simple. It uses two cameras with a magnification of more than 300 times to capture the position of the optical fiber, and then uses the built-in computing chip to perform image recognition. Control the core adjustment mechanism to align the optical fiber, and then use discharge to generate a high temperature of more than 1,000 degrees to fuse the two optical fibers together. Although this process sounds simple, the diameter of the optical fiber we commonly use is only 125 microns, and the fiber core is only about 9 microns, which is thinner than a hair. Therefore, in order to successfully complete the process and achieve a satisfactory splicing effect, this product is actually very technological. Those optic fiber fusion splicers on the market that look similar in appearance actually have very different structures inside, and the manufacturers are even more uneven. Therefore, if the user is not careful, it is very likely that not only will he waste money, but he will also delay work and offend the client. So how do we avoid the pitfalls? Below, we will answer your questions one by one from a purely technical perspective. Number of motors. For common fiber splicer machines, the number of motors is usually divided into 4 or 6. What is the difference between the two? Simply put, models with 4 motors cannot adjust the focal length of the camera, while models with 6 motors or more can adjust the focal length of the camera. So what impact will this have on the optic fiber fusion splicer? The 4-motor model, also known as the fixed focus fiber fusion splicer, is used by most of the cheap models on the market. So what's the problem with it? The problem is very serious. The fixed focus lens cannot change the focal length. In order to identify the optical fiber, the magnification of the camera is usually more than 300 times. Under such a large magnification, a slight position change will cause the focal length of the camera to shift. During use, dust accumulation and mechanical deformation are inevitable, which will cause the V-groove to gradually deviate from the optimal recognition range. The imaging of the optical fiber will become more and more blurred. The blurred edges will affect the optical fiber fusion machine's recognition of the image edges, and ultimately affect the alignment of the optical fiber. Although this problem can be solved by cleaning the V-groove in the early stage, when the above errors accumulate to a certain extent, ordinary cleaning and adjustment can no longer bring the camera back to the correct focal length range. Most users cannot solve this problem on site, and can only return the camera to the factory for repair, which will not only delay work, but also likely result in high repair costs. The 6-motor fiber fusion splicer does not have this problem. When the V-groove deviates from the focal range due to dust collection, it can automatically adjust the focus to bring the focal length back to a reasonable range, ensuring the clarity of the fiber optic image without delaying work. Currently, the vast majority of imported high-end models on the market, as well as most of Signalfire's products, use a 6-motor structure. Even if errors occur after long-term use, they can automatically adjust to the optimal position, perfectly avoiding the problems of 4-motor models. Although the 4-motor model is cheap to purchase, it needs to be cleaned and repaired frequently during use. Even if you choose a product from a reputable manufacturer with reliable free after-sales service, such as the AI5 from SKYPE, frequent maintenance and repairs can still easily delay the project. If you choose a product from a small factory, the consequences will be serious. Not only will you often have to pay high repair costs, but you may even find that the small factory goes bankrupt and you can't find anyone to repair the machine, causing it to become a brick. Therefore, unless there are special reasons, it is not recommended to buy a 4-motor fiber fusion splicer. Although the price of a 6-motor fiber fusion splicer is slightly higher, its stability and reliability are much higher, and its comprehensive use cost is much lower than that of a 4-motor model. Therefore, it is recommended that users should give priority to this configuration. Whether the camera can focus determines the basic performance of the optic fiber fusion splicer. While the structural type of the core adjustment mechanism is related to the quality of optic fiber fusion splicing, there are two common types of core adjustment mechanisms: micro-arm parallel cam structure and lead screw structure. Micro-arm parallel cam structure. Micro-arm bracket, cam drive. This structure has poor accuracy because the micro-arm is too short, and it is difficult to ensure the processing accuracy of the eccentric wheel or Archimedean screw mechanism used as the cam in mass production. In addition, the friction between the cam surface and the ejector rod for a long time causes rapid wear, thus making the overall centering accuracy even lower. Since the diameter of the optical fiber is only 125 microns, and the fiber core is only about 9 microns. In order to achieve precise alignment, the error must be less than the micron level. The micro-arm parallel cam core adjustment mechanism is difficult to achieve this due to defects in mechanical principles. This determines that the optical fiber fusion splicer using this mechanism naturally has higher fusion losses. Lead screw structure adopts herringbone bracket and screw drive. Due to the long deformation arm, the accuracy is naturally high, and the screw propulsion ensures good reliability. The core adjustment accuracy can easily reach hundreds or even tens of nanometers, so the welding quality is better. For example, in the market, the widely acclaimed SKYPE AI9 has an accuracy of 0.1 microns, while SKYPE's latest AI30 has reached 0.05 microns. Therefore, the entire series of SKYPE products and some imported high-end models all adopt this advanced structure. Therefore, when choosing a fiber fusion splicer, you must pay attention to the core adjustment structure of the welding machine. Another factor that determines the accuracy of optical fiber alignment is whether the lens can achieve fiber core alignment. Although theoretically, the core of the optical fiber should be in the center of the fiber. Due to the different production quality of each optical fiber manufacturer, the core of some optical fibers is not in the center of the fiber. There will be a certain deviation. Currently, there are two types of cameras. One that can only see the cladding of the optical fiber, and the other that can see both the cladding and the core. If the amount of splicing is very small, and there is no requirement for loss, cladding alignment is sufficient. However, if it is for operators, railways, engineering companies, and business companies to construct optical cable lines, maintain lines, emergency rescue, security monitoring, and teaching research, it is recommended to choose core-aligned ones. It is recommended to choose AI9, AI20, and AI30 series from Juoshi, or imported high-end models. There is a large price gap between these two different lens types, and users should carefully consider the cost-effectiveness based on their business scope. In addition to alignment accuracy, the most important factor affecting the quality of optical fiber fusion splicing is fusion discharge. Theoretically, the splicing process is divided into dust removal, pre-melting to soften the end face, overlapping splicing to connect the optical fiber. However, in the actual splicing process, due to factors such as vibration, optical fiber impurities, arc impact, etc., the optical fiber will have jitter, misalignment, and power changes at the moment of discharge, which will lead to increased welding loss and insufficient splicing strength. Low-end fiber fusion splicers are usually unable to capture image changes in real time during the discharge process, perform recalibration, and adjust the current. However, high-end fiber fusion splicers can collect up to hundreds of real-time images of optical fibers during the discharge process and adjust the position of the fiber core and the current intensity at any time to achieve the best discharge welding effect. Therefore, The computing power of low-end splicing machines and high-end splicing machines is completely different. Currently, Signalfire's AI-20, AI-30, and some imported high-end models all have this capability. With the current production cost, it is difficult to have the necessary hardware configuration for this capability at a price below $570. In addition to the performance of the Fusion Splicer itself, the method and quality of the fiber optic cleaver is another important factor that determines the fusion splicing effect. There are usually two criteria for judging the quality of optical: fiber cutting, end face cutting angle, and end face flatness. Traditional mechanical cleaver. The blade cuts a small notch on the edge of the optical fiber, and then uses an elastic fiber board to press the optical fiber down and break it, using stress diffusion to form a smooth end face. Mechanical cleavers are prone to causing end face damage due to contact with the optical fiber when striking. In addition, some mechanical cleavers can automatically return the blade, which can also cause secondary damage to the optical fiber end face when returning the blade. The advantages of mechanical cleavers are simple structure and low cost. The disadvantages are unstable effects and the need for frequent adjustments. In order to make this type of cleaver work well, it must have extremely high processing precision. The price of high-quality imported cleaver is usually more than $142. Those below $20 are usually of unstable quality and have a short service life. In addition to the above-mentioned mechanical cleaver, there is also an electric stretch cleaver, which can effectively avoid the problems of the above-mentioned mechanical cleaver. But it is relatively expensive, has a slightly lower efficiency, has high requirements for the operating environment, and is very difficult to produce. Currently, only Signalfire's AI-10 and some high-end brands are equipped with it. So is it possible to combine the advantages of the two types cleavers? Signalfire recently launched a world-first blade delay return electric one-step cutter, which combines the advantages of fast cutting of traditional mechanical cleavers and stable cutting effect of electric cleavers. It is easy to operate, efficient, has good cutting quality, and does not require blade adjustment. Compared with Signalfire's own AI-10 pure electric cutter, it has significantly improved efficiency and lower usage requirements. It has been installed on Signalfire AI-20 and AI-30 and is currently the most advanced fiber optic cutting method. When choosing a fiber fusion splicer, you must consider the type of fiber cleaver that the machine is equipped with, because this is also an important factor affecting the price. In addition to the above aspects that require attention, we must also be aware that any optic fiber fusion splicer cannot be perfect at the beginning of its design, and will inevitably encounter various unexpected problems during use. Therefore, an optic fiber fusion splicer, produced by a good manufacturer, must have both hardware self-checking function and software wireless upgrade function, so as to repair various unexpected bugs at the beginning of the design at any time. This is also a key configuration that we must pay attention to when choosing a fusion splicer. To sum up, an excellent optic fiber fusion splicer must be able to automatically adjust the focal length of the lens, accurately identify the cladding or core of the optical fiber, have a reasonable structure for the core adjustment device, be able to achieve high precision alignment, and have sufficient hardware computing power. The equipped cutter must be able to work reliably, realize self-detection, and support remote network upgrades. This is the ideal optic fiber fusion splicer. We should choose to reduce our usage costs and improve our work efficiency. Well, after hearing so much hardcore content, have you learned how to choose a fiber fusion splicer? If you can gain something from this video, don't forget to follow, like, and share it. Thank you.